Today's talk is about decision matrices. In engineering decision, as in decisions in general, it's often insufficient to just have economic information. You may know how much something costs, but unless you know other features of it as well, you can't really make a decision. Other features might include safety, comfort, attractiveness, all kinds of things that affect our choice over alternatives, but we really can't include into a strict economic analysis, or sometimes can't even deal with quantitatively at all. Now, there are a lot of ways of dealing with this problem of having a lot of different criteria to consider in decision making. And the general area is called multiple criteria in decision making. And we can deal with the multiple criteria in a problem off the top of our heads, just using our experience and feelings about the alternatives. But it's usually better to make a formal analysis, especially in a business context or an engineering context where you want to have good reasons for making a decision. Now, one of the techniques that one can use to do this is called decision matrices. And it has a number of features which make it quite attractive for practical use. And I've listed a few here. First thing is that it does include all factors you want to, all different criteria that are involved in the decision, into a formal and quantitative comparison, even if the factors are non-quantitative. That is, they're hard to put numbers to begin with. It also makes sense. It's intuitively reasonable. The results are easily communicated to an unsophisticated client or manager. One of the problems that we engineers have sometimes is that we use fairly sophisticated techniques to come to decisions, and our clients or our supervisors, who are sometimes not engineers, have to accept us on faith that what we're doing is reasonable. And one of the advantages of decision matrices is that the client or manager can understand what we're doing. It's very clear, and they can actually help us do a good job at it. And the fourth thing is that in all decisions, our information is sometimes imprecise or ambiguous, and it's really important to do sensitivity analysis. And decision matrices are designed in a way that it makes it easy for us to do that kind of sensitivity analysis. Now, a number of steps to using decision matrices. And I'm going to go through these steps with respect to an example of me buying a car. I bought a car a year or two ago, and I had a choice of alternatives for which car to buy. And there was a number of different factors that affected my choice. So this choice is typical of any engineering decision, whether we're buying a piece of plant for equipment, or choosing a supplier of stationery, or choosing what recycling scheme to use for our waste products. So it's a typical problem in its structure, although it's a personal problem for me. So the first step in any problem is to list the criteria under which the alternatives will be judged. Now I have a little chart here, and I did actually this chart on Excel, a spreadsheet program. And spreadsheets are often the easiest way to develop these decision matrices because they can save you quite a bit of computational labor. You can see I have the chart set up with alternatives as columns and criteria as rows. So my alternatives for my car buying problem were a Taurus station wagon, an MPV, that's a Mazda minivan, or a Caravan, which is also a minivan. So I'm listing my alternatives in the columns. Now under the criteria, these are the factors which affect my decision. Certainly cost is an important factor. And for me, the reliability is important because I live out in the country, and I don't want to get stuck by the side of the road on my way to work one day. And then comfort. I'm a very tall person, and small cars are very uncomfortable for me to drive. Now, I could have other criteria here, and there could be other alternatives too, but for this example, I'm using 3 alternatives and 3 criteria. So I've now listed the alternatives and the criteria. Step 2, give a weight to each criterion to express its relative importance. The higher the weight, the more important the criterion. Choose the weight value so they sum to 10. So that's this shaded in column I have, the first column after the criteria for the weights. Now I want these to sum to 10, so in my spreadsheet I'll put a little formula down here that adds these weights up so I can see when they sum to 10. And I'll explain why we want them to sum to 10 later. But for me, I think cost is more important, so I might give it a weighting of 5. Reliability, second most important, I'll call it a 3. And comfort, third most important, and I'll call it 2. Now, these happen to be listed in order from most important to least important, but that's not important. I could have had comfort third in order here, it doesn't matter. What indicates the importance is the magnitude of the weights. The higher the weight, the more important the criterion. You also might recognize that these are kind of arbitrary, but as part of our sensitivity analysis, we can change these around to see what effect that will have on the final results. So the third step. For each alternative, give a rating from 0 to 10 as to how well it meets the corresponding criterion. A rating of 0 is given to the worst possible fulfillment of the criterion, and 10 to the best possible. That's what goes in these cells here. What this means is that I think about how the torus meets the criterion of cost. And if it's a cheap car, I'd give it a high rating. And if it's an expensive car, I'd give it a low rating, because cheap is better than expensive. Now, it so happens that the torus was fairly cheap, and a 9 would be a good expression of how well it fits that criterion. The cheapest car would be a 10. The most expensive car would be a 0. I can imagine there might be a cheaper car than the torus that would meet my needs, even though it's not my list of alternatives, which is why I only give it a 9. The MPV is fairly expensive. I might give it a 2, and the Caravan a 7. Now again, these are a little bit arbitrary too, but we can also change those in our sensitivity analysis. What we're doing is expressing our best estimate of how well the alternative meets the criterion at this point in time. Similarly for reliability, it turns out in my judgment the MPV is the most reliable, and in fact it's the most reliable car I can possibly imagine, so I'll give it a 10. Whereas the Taurus doesn't really have much of a reputation for reliability, I'll give it a 4, and neither does the Caravan, I'll give it a 3. For comfort, having sat in all 3 cars, I found the Caravan most comfortable, but perhaps there could be one more comfortable, so I'll give it a 9, the MPV a 7, and the Taurus a 4. Step 4. Multiply each rating, that's the numbers in the matrix, by the corresponding criterion weight, and sum for each alternative to give an overall score. So what I do here is I take the rating here of 9, I multiply by the weight of 5, and add it to the rating of 4 multiplied by the weight of 3, and the rating of 4 multiplied by the weight of 2. And you can see what that'll give me is kind of a weighted total here, where the criteria that are high and have the highest weight will contribute most to the total. And if it's criteria that are low and have low weights, contribute very little. So 9 times 5 is 45, plus 12 is 57, plus 8 is 63. 45, 57, 63. I think I did that wrong, because it should be 65, but I'll continue. And the next one is 54 and 62. Yeah, it's 65, of course. Now, in step 5, we then evaluate the criterion. The criterion with the highest score is best, which is kind of common sense. Also, the value of the score gives the percentage to which an alternative approaches an ideal solution. Let me explain those two. First of all, the alternative with the highest score is best is kind of clear, because you're totaling the ratings and the weights together, so that the weights kind of reflect because they reflect, they are the most important criteria, the fact that you value that criteria more, and so for a higher weight will contribute to a higher total value, makes sense. Also, the higher rating contributing to the higher total value makes sense too, because it scores well with respect to that criterion. So Taurus is the best of the three, because it has the highest total score. So that's the relative interpretation of these scores. But there's also an absolute interpretation, and it has to do with why we sum these weights to 10. Because let's say we had a perfect alternative that scored 10 on each of the criteria. Because the weights add to 10, if a perfect alternative scored 10 on each of the criteria, the total score for a perfect alternative would be 100. So there's also an absolute interpretation of these numbers too, as the percentage of an ideal alternative that each of these alternatives meets. So even though the torus is best, it's really only 65% of the ideal alternative. And that's useful information to know too. Because this total score then is fairly low, and 65 is kind of low. It suggests that maybe you should go out and look for more alternatives, because you might find one that in fact has a better absolute score. So, in summary, the decision matrices allow you to take into account all of the factors that contribute to an overall decision. It's rigorous, it's quantitative because of these choice of values, and allows you to come up with a number that reflects the value of each alternative. But of course, sensitivity analysis is really important. What you want to do is put this on a spreadsheet, so it's easy to go and change these weights, change some of the values of these ratings for the alternatives, and see how the final results are affected. If in fact these results are robust, that given a wide variety of weights and ratings, torus is always the best choice, then buy the torus. If not, if other alternatives come up under different circumstances of weights and ratings, then it's more important that you really come to a firm decision as to what these weights are and what the ratings are. So having this on a spreadsheet is really valuable. Now, I will give you a more comprehensive example in a later talk. Thank you.